friends, associates, compadres, lend me your engineers. Hello and welcome to Lend Me Your Engineers. My name is Paul.
And I'm Cameron.
And we are your hosts. We are your tour guides through this fascinating, cutting edge, and sometimes downright wacky world of engineering. Now, in the interest of full disclosure, neither Cameron nor I are engineers. We are not engineering students. I don't even go here. But we do work here. We both work for the UCF Department of Mechanical and Aerospace Engineering. So while I might not have the scientific or academic background to talk about engineering, I am definitely qualified to talk to engineers. And that's what Lend Me Your Engineers is all about. People talking to people. Some people will talk about turbine engines, some people will talk about heat transfer, and some people will talk about the mechanics of lightsabers and how close we are to having real lightsabers. I really want to talk about lightsabers. With that said, I did want to bring some scientific legitimacy to the show, so I asked the smartest person I know to be my co-host. And unfortunately, that person was not available. So instead, I asked Cameron. No, but in all seriousness, Cameron is one of the smartest and most well-spoken individuals that I have ever met, and I am very thankful that he agreed to lend his talents to the show. The great thing about Cameron is that he has a lot to say, so if there's ever a week where we can't find a guest, I'll just ask Cameron a question and just sort of let him go. But for our first show, we actually do have a guest, UCF MAE Assistant Professor Andrew Dickerson. We had such a great time talking with Dr. Dickerson that we decided to turn his interview into a special two-part episode. So today you will hear about his research inspired by nature and how you can tell if a mosquito is a boy or a girl. Then next week you will hear about his unconventional route to becoming a professor here at UCF. So a couple weeks ago, I had the chance to check out your lab for the first time during the Camp Connect event, where they had the students from the middle schools come to the university and see what everybody's up to. And in your lab, you have this cube, this clear cube that is just filled with mosquitoes. What is going on there?
You know, Paul, if you'd told me years ago that I'd be doing mosquito research, I'd have told you were crazy. I don't have an interest in bugs, right? Mm-hmm. Well, I do now. I have an interest in bugs now. So we do a lot of work with mosquitoes. We get our mosquitoes from another researcher at UCF who rears them.
What? Wait a minute. There's a guy whose job is to breed mosquitoes.
Well, there's a professor who hires people whose job it is to raise mosquitoes, yes. So we get these mosquitoes, and you know, as a mechanical engineer, we're interested in how they interact with their environment. Mm-hmm. I'm not a biologist. I'm not a toxicologist. I don't care a lot about the cellular interactions that are going on or whatever. But I do care about the physics of how they move, how they survive different scenarios, how they find things. And what we're doing now, and probably the experiment that you saw, is that we're filming mosquitoes taking off from different surfaces, and we're trying to understand how the effect of surface roughness changes the strategy by which they use to take off. So we've got some surfaces in there that make mosquito legs slip if the mosquitoes kick off when they take off, and we have other ones that are about the same roughness as human skin. And the idea is to understand, how does the surface affect like the takeoff performance. We're also interested in how they land on different things, how they land on moving targets. How do they perceive the targets? How do they adjust their flight dynamics as they're coming into the targets, particularly if the target is complicated? What I mean by that is if it's got like a very non-uniform surface texture. You can imagine like a hairy arm or leg, right? Mm-hmm. So how do they engage surfaces like that? How do they search for, find, and navigate holes and different barriers? Whether that be like, your screened-in porch has a hole in it, right? And you realize, oh crap, I'm getting bit by a mosquito back here. Mm-hmm. Now, how did that mosquito find that hole? And how did it get through there? And then what is the smallest hole that they can get through? Or alternatively, you could think of it as, how big can a hole be before it allows a mosquito to get through? Mm-hmm. So that's just some of the ideas or some of the things that are going on with mosquitoes in our lab. Some of the other kind of cool stuff we're looking at is we're looking at these little microjets that come from citrus fruit. So if you ever notice when you're maybe peeling an orange or something, number one, it smells super good. But
Sure.
you also notice that you maybe have oily hands, and if you look really carefully, you'll notice this little fine mist that kind of bursts from the orange as you peel it. So we're looking, with high-speed video really closely at these little jets and trying to figure out how fast they're going and how does the material properties of these orange peels enable this high-speed, explosive sort of emptying of these little oil glands dotted along the fruit surface. We're also looking at how fur is able to stay clean. So with the connection we have in the biology department, we're growing bacteria on different furs and looking at how fur cleans itself and how resistant is it to bacterial growth and that sort of thing. And really what inspired me there was I don't really remember exactly what I was looking at the time, but I think, okay, anything that's submerged underwater for any period of time has a lot of crap that grows on it, whether that be the underside of a dock or a bridge or a boat, and things like fish and semi-aquatic mammals, etc., don't suffer this problem. Semi-aquatic mammals probably, they look a lot different than fish do, obviously, and they have a different mechanism for staying clean. And this sort of anti-fouling property, or the resistance to getting fouled by all these, algae and bacteria and all these different growth media. That's called anti-fouling. It's pretty well understood how fish manage to do that. They're very mucousy. But with a furry beaver or an otter or something that is constantly wet, it's unknown how they're able to not be covered with algae and covered with bacteria and these different things that grow on every other, constantly or frequently submerged surface. So that's kind of a topical survey of what we're looking at now in the lab. And as you might have figured out by this point, everything that we do is inspired by nature.
Mm-hmm.
So we'll take a natural problem and we use these engineering tools to study it and characterize it from sort of a physical point of view. And this is certainly a carryover from what I did in graduate school, and really one of the reasons that I decided to do research in graduate school is I found a professor that was doing something different. I found someone that was as fascinated with nature as I am, and taking an engineering perspective at different natural problems, and that's what makes research fun for me, and I can plan to continue doing that for the rest of my career.
What I think is really interesting about your research is that you're not trying to discover a way to kill the mosquito. You're just trying to annoy him by making things slippery, so he'll just like whoop and fall down.
Oh, I would love to figure out a way to kill Mr. Mosquito. Well, Miss Mosquito, as it were. The females are the only dangerous ones.
Oh, is that true?
That's right. Yeah, male mosquitoes don't bite people. Only female mosquitoes bite people.
What?
Because they're carrying they're vector carriers
They need protein to make eggs.
Eggs. Yes.
This is the point in the show where you realize that Cameron knows a lot more about science than Paul does. He doesn't really know what you're talking about.
There was a time in my life where I got really, really interested in why mosquitoes bite people. So I learned about plasmodium and other things like that, and like proteins and egg growth. I get these spurts of like, why is this thing the way it is? And I just deep dive into everything.
So are all the mosquitoes that you're studying male, or are they female, or
we have a mix of both, right? So for takeoff studies, we'll look at males and females. But if we are, say, concerned with a particular, maybe a new novel way to control mosquitoes, whether that be a new sort of insecticide, or we're trying to look at how mosquitoes find holes in barriers, we'll only use females for those.
How can you tell?
You can actually,
They have little bathing suit areas.
Funny enough, you can look at a mosquito and by the kind of the They look like little feathers coming off their antenna.
Uh-huh.
Males have the feathers and females do not.
Wow. So what purpose do the males serve? Just to repopulate the species?
Yeah, man.
Oh, I'm talking about the mosquitoes now.
You know, you got to have two parts.
That's true.
But,
Well, there are some that don't.
There are a couple of lizards actually that can change their genders at will, and they reproduce.
That's what happened in Jurassic Park. That's how the dinosaurs got out.
Just food for thought. that is a real thing. That happens.
How did you come to specifically study what you're studying? Are these things that you chose that were interesting to you, or was this something that was like you were grandfathered into this research?
you're talking about here at UCF?
Yeah, like these, like what we just talked about, like the oranges and the mosquitoes.
So I think you tend to gravitate towards the things that you're comfortable with, which I do, but I also realize that I have to push the envelope to some degree. I have to differentiate myself, and so I'm trying to kind of find a nice balance of both. The citrus oil stuff, funny enough, was a carryover from the first thing I ever did in Dr. Who's lab as an undergraduate. Okay, so I can't take credit for the idea. That semester, I was able to take a lot of pretty pictures, with these exploding orange peels and characterize, the size of the glands and roughly approximate the pressures inside when they burst. But that project never really saw a satisfactory end. Really, I had just kind of scratched the surface as an undergraduate. So, after my tenure as an undergraduate researcher in that lab, the project never went anywhere else. So when I was starting this job, I thought, okay, what's a good, fun, highly visual project that I can kind of use to get my student indoctrinated into using the equipment, which is mostly high-speed videography and microscopy, and have something that's kind of beautiful that we can put out of our lab within a relatively short period of time. And this came to me as, hey, this was unfinished business as far as I was concerned. So my advisor, Dr. Who, graciously allowed me to kind of pick up the ball and run with it. And so that's how that project came to be. I work with mosquitoes now, I suppose because I worked with mosquitoes in graduate school, and that doesn't sound like a very good reason, but the reason we initially landed on mosquitoes years ago is because they are so easy for us to get. If you want a lot of insects for study in your lab of in flight mechanics, you don't have too many options that are easy. And we tried a few different things. One option that you have is going to some of the genetic researchers and getting fruit flies. The problem with fruit flies is they're very small. Okay. Another thing you can do is you can order fly larvae online, like housefly larvae. The problem with those is you don't really know when the flies are going to emerge from their pupae, and they stink really bad. So,
which is a negative.
Which is not something that's very pleasant to have around in a lab. That people that aren't doing insect research don't want to be around a smelly tank of flies buzzing around. So, we tried that a little bit, and that didn't really work out either. And not to mention, as you wouldn't think, but flies, when you put them in a small container, they don't fly. Yeah, go figure. They walk and they crawl. They don't want to fly. They fly around the room like crazy, but constrain them to a small space, and they really don't want to. Mosquitoes are different. You can put them in a small container, give them a little bit of stimulus, generally like your breath, a little breath of air, and they'll go berserk in response to the CO2 that they're measuring in your breath. So we landed on an insect that was in steady supply. We got them from the CDC. Was about the right size, not too big, not too small. Easy to keep alive in the lab. Just feed them sugar water, and they will drink that.
Just like Cameron.
Yeah, right. Just sugar water.
Just like a 10-year-old, man. They can survive just on sugar water just fine, and They fly in enclosed spaces. So it was a really convenient model organism to do a lot of these biomechanics studies on, and with the added benefit that any research that you do with mosquitoes, adds to sort of the mission of controlling them as the world's most dangerous animal.
We had that Zika outbreak. I don't think it quite reached us here in Central Florida, but it was a big deal. Was it last summer?
In Miami? Yeah, it was.
Yeah. And
fall,
you still hear
summer,
about it. Did that add anything to your research, or did that make you think this will be very important?
It's certainly validating.
Mm-hmm.
And I think what it has done is it has brought kind of mosquito research to the forefront in terms of perception of importance within the scientific and the general community. I certainly haven't been able to capitalize on Zika control just yet, but hoping that something will come along, right? Some collaboration, some fresh idea, as we look as we look deeper into the mechanics of their behavior and their survival, that something will pop out of that. What I've found in the past is a lot of the greatest endeavors we kind of stumble on by accident. In fact, some of the stuff we're doing currently with mosquitoes, looking at their taking off and things, was never really the intention. We just kind of made a serendipitous discovery in some of our films that sparked us to think, okay, let's take a deeper look here. We're looking at collaborating with our mosquito supplier, Brad Willenberg, in the College of Medicine, and trying to understand, maybe how mosquitoes interact with plumes of repellents and that sort of thing, to broaden our understanding of, just how mosquitoes do perceive toxins in their environment, and then that will inform us how to better disperse these toxins and effectively keep mosquitoes away from us.
Is the goal to just eradicate the species of mosquitoes, or do you need at least some because there are other insects and other creatures that feed on them? And that would just set off a butterfly effect that who knows where it could end.
Yeah, maybe you're asking the wrong guy, right?
You're just trying to make them slip. Whoop.
Well, yeah, I'm just trying to understand how they work, right? And so, the more we know, the better prepared we are.
Sure.
Yeah.
I do not condone total eradication.
Oh, okay.
Because I think we don't know what sort of consequences that will have.
Right.
Yeah.
And I would say that most people in mosquito control would not promote total eradication.
Well, sure, they'd be out of a job.
In fact, this may be surprising. The trend is going towards less death and more repellency.
So just keeping them alive, but just away.
Right. Because what is happening is we're developing insecticides that work for a time, and then because we're basically using these insecticides to kill away the mosquitoes against which the insecticide is effective. Well, what you have left is a few mosquitoes that are resistant to this particular
super mosquito
chemical that you've created. So then now you have these super mosquitoes that breed and grow, kind of through, I don't want to say natural selection, but at least selective resistance. And we're having to develop new insecticides all the time to kind of combat this problem. So the insecticidal approach is ultimately not sustainable. So instead of trying to just kill as many mosquitoes as we can, what's better is taking away this selective pressure and just trying to keep them away from us.
To live in harmony with the mosquitoes.
If you want to call it that. I would say live in harmony away from mosquitoes.
Sure.
You let them be, and let them feed on all the squirrels and the deer and everything else, and leave us alone.
I mean, hopefully, the other things that they feed on have selective resistances to whatever they're transferring, rather than human beings.
Have you ever considered studying something a little more adorable, like puppies?
I'm very much an advocate of keeping animals out of the laboratory as best we can. So I don't feel a lot of guilt when we squash a mosquito in the lab, but I certainly don't want to do any work with any vertebrates in the lab if I can help it. So
How far are you willing to go? Lizard? What is a vertebrate? Again, I know nothing about science.
So something with a backbone.
Backbone, okay. So snakes are okay?
snakes, I would be okay doing something with snakes, but I don't really have a lot of interest in snakes. So there you go. There are other people in the country that are doing research with snakes, and I know some of them that are very good at it, and I will let them continue to doing the great work that they do, and just keep kind of plugging away at some of my own ideas, and there's more ideas than there are people in my lab to pursue them. So
and this might be a question for another time, but growing up, did you always have this interest in nature that you have now?
No.
All right. Well, tune in next time to find out the answer. No, I guess that was the answer. No is the answer.
No.
All right. Well, thank you so much for joining us.
Well, let me say this. Maybe this for this podcast or another one. I was not the kid that was out in the yard turning over rocks looking for spiders. Okay, or chasing down snakes and lizards and keeping in my bedroom. I was not that kid at all. Nor was I the kid that was taking apart my dad's old things to see how they worked. Okay, so the irony is not lost on me that I kind of ended up here. I think I did have a general fascination for how the world worked, right? It didn't necessarily mean that I needed to open up every little mechanical device and check out its inner workings. And on occasion did that, I'm sure, and would kind of marvel at the elegance of a lot of things we have. Heck, I still do that. I worked on a little lawnmower carburetor last night and was just absolutely impressed how complicated something that small is, and how relatively simple in function that something like that is, but still quite ornate. But just kind of this I guess a higher level curiosity about how things work, and as I've gained knowledge and matured and kind of found my scientific identity, that fascination with the broadness of how things worked hasn't gone away, but it has been enhanced by kind of this distilling down into the minutia of the physical interactions that make our world what it is.
Is there anything that you have an interest in studying that you haven't had the opportunity to study yet that you hope to?
I'm really hoping that at some point in the future I can do something with honeybees. And I say that because I'm absolutely taken by how they can function as a group, but also function individually, and how they go collect masses of pollen, bring them back to the hive, et cetera, et cetera. But I'm also as many scientists are, really concerned about the reduction in their population and these mites that infect colonies and things. And if I could do something with honeybees that helps that survival rate, or helps reduce the amount that we lose, that'd be really satisfying. I haven't kind of drummed up the silver bullet yet, right? Or even a solid direction on where to go in that arena, but it's certainly something that's on the back of my mind.
Well, I am deathly afraid of bees, so please let me know when you have them in your office so I can avoid them at all costs.
It looks like he's on the opposite spectrum. He wants to reduce mosquitoes, but improve populations for honeybees.
That's right. The balance between the two.
There you go.
Bring balance to the force once and for all.
Once and for all.
Obi-Wan never told you what happened to your father.
He told me enough. He told me you killed him.
No, I am your father.
No, that's not true. That's impossible. You're only like 10 years older than me.
Search your feelings, you know it to be true.
No!
And that was your reward for listening all the way through to the end of the podcast. Well, Cameron, we did it. We made a podcast. I want to thank our guest, Dr. Dickerson. We will hear more from Andrew next week. I also want to thank Cameron.
You're welcome.
I know you didn't get to hear too much from Cameron this week, but I promise he will have a working microphone. Well, not next episode, but eventually, hopefully. I also want to thank Maddie, the Black and Gold Studios director. If you are a UCF student or employee and you're interested in starting your own podcast, Maddie is definitely the person you want to talk to. You can find out more about podcasting at osi.ucf.edu/blackandgoldstudios. Until next time, remember, there's a great, big, beautiful tomorrow shining at the end of every day, and tomorrow is just a dream away.